All right. So some of you actually did send something, and they were having some questions. Okay. So I will. So I have already probably promised some of you to talk over the phone after the class, maybe. But let me actually, while the class is going, I'll also talk about the same problem and how to implement it on Matlab and what kind of difficulties we are going to get, okay, and how to resolve those difficulties, okay. All right. So just to remind you, I think so I just quickly browse over the equations which we were supposed to solve for PFR with axial dispersion, and the equation that was a differential equation that read del square Ca by del z square minus Peclet number del Ca by del z minus Rca equal to 0. Okay, I'm not writing stars anymore. That will be a little cumbersome to write. Okay, so I'm avoiding writing star, but you know these CAs. So these CAs are dimensionless concentrations. This Z is a dimensionless length. Okay, and Peclet and R, we all remember that what those quantities are, right? So this is my differential equation, and uh, the non-trivial thing about this problem is a boundary condition. Okay, that is what makes it non-trivial and interesting and difficult to solve. Okay, so boundary conditions which are referred to as Danckwert's boundary condition. Okay, so this was so at z is equal to 0, I will be having the condition that Ca minus 1 by Peclet number del Ca by del z equal to 1, and at z equal to 1 I'll be having um, del Ca by del z equal to 0. Okay, so this was our problem statement, and what we decided to do is, so the shooting method. So now this is what we are going to solve by shooting method. Okay, and in shooting method, what we do is we identify essentially two quantities, Ca and Ca prime, which we are going to call, which is essentially del Ca by del z. These two become our variable, and we track both of these as we change along, as we move along z. Okay, so let's say, so these are the new variables. Okay, so and these two variables I will obtain first order ODE. So I can write down this as del Ca by del z equals to Ca prime, and del Ca prime by del z is going to be equal to P Peclet number and Ca prime plus Rca. Okay, so this is essentially having this form, which is del y1 by del z equal to f1 of y1. So all the y's basically. Um, this would be f z of z y1. Okay, y2 del y2 by del z will be f2 of the same arguments, and so on. Essentially, this can be written as this is a vector equation, and in a concise manner, this can be written as del y by del z will be equal to f vector of z and y. Okay, so just an analog of the one-dimensional case. One-dimensional equation would read as del y by del z equal to f of z comma y. As this is just one scalar, one number. I have multiple dependent variables y1, y2, etc. depending on z and y1, y2s as well on right hand side. Okay, so this is actually this is the this is a IVP in a for multivariable. Okay, and this is exactly the same form I have here. So I have y1 can be identified with Ca, y2 can be identified with Ca prime, f1 can be, in this case f1 is known, which is just C y. Okay, just y2 is f1. and f2 will be given by this quantity where it's a function of y1, y2, and etc. Okay, there's no explicit dependence on z on right hand side here. Okay, so this is essentially the same kind of formulation. Okay, so it's an IVP. Okay, in multi or many dependent variable, multiple dependent variable. Okay, so this is what I had to solve, right? So now this can be solved by any of the IVP solver that we have discussed methods. We are going to use today, we will use Rk4. Okay, so okay, so Rk4, I hope you all remember. It's a very standard method, and I suppose all of you are familiar with the I have given you the basically the scheme for implementing that. Okay, I don't have yeah, okay, here maybe. So Rk4. So if you have this kind of equation, let's say dy over dt, but t and z are equivalent, so these are, I don't, it doesn't matter whether you call it t or z, it's an independent variable. That is equal to f t comma y. Okay, this is the same form over here, divided by fz comma y. Okay, so this form essentially just changing t to z. That's all. So Rk4 method consists of implementing these steps. You just say k1 vector is going to be equal to f at any, it's a basically iterative method. So at nth step, okay, you have to start with a guessed value, of course. Okay, so first step will be 0th step, and nth step I calculate the next value of y by implementing these steps first. This is given by Tn plus delta t by 2, where delta t is my, it should be vector, yn plus delta t into k1 vector by 2, k3 equals to, and this has to be done sequentially because k1 is used in evaluation of k2. K2 is used in evaluation of k3. So you have to first implement this step, then this, and then this, and so on. Okay. So k3 will be equal to f of tn plus delta t by 2 and yn plus delta t k2 by 2. These are vectors. Don't stat up, and k4 would be equal to f vector tn plus delta t and yn plus delta t into k3 vector. And then finally the last step is calculating your next y, would be given by yn plus h by 6, and these vectors k1 plus 2k2 plus 2k3 plus k4 vector. Okay, this is your scheme for implementing Rk4, as simple as that. Okay, so let's do that. And okay, so all right, so let's try to do that in Matlab now. Any question about this? Okay, so how do we implement this? Well, I have doubt. We can, yes, Rohit, that we can calculate delta S by second method, but how we get next G of S? Okay, yeah, well, acha. So, well, I have not, okay, maybe, so maybe I can spend a little more on this. So, second, so now this, what you do is you, so if you look at this condition, boundary condition here, at the left end, okay, at the left end, that is z equal to 0, I have this equation has to be satisfied. Now I do not have either CA or del CA by del Z specified at the left end. Okay, shooting method consists of knowing the initial values, okay, at t equal to 0. Okay, so basically you need to have y, this y at t equal to 0 has to be known, so that this y vector has to be known at t equal to 0, so that you can implement this step, right? These are Rk4 steps. Now CA0, so y0 here, meaning I need to know both. Remember, y is a vector consisting of the value CA and its derivative CA prime, right? So y is essentially, in this, in our case, y is equivalent to having, so here this y is, in our problem, y is, sorry, CA and CA prime, the solution and its derivative. Okay, so having it 0, meaning I need to know both CA and CA prime at t equal to 0, right? Having these values at initial values, meaning I need both the conditions, right? So well, but we are not given any of those. So the method consists of approximating or guessing any one of those, of course. Okay, either you can guess this value or this value, okay, at t equal to 0, and once you know any of those, the other can be obtained from this condition, right? So your code, you can code it so that you can start by guessing this, or you can start by guessing this. Okay, and then so if you recall now, okay, so if you recall, so what happens is you start with the left end, and then you calculate y at the rightmost end, that is z equal to 1. Okay, there you calculate CA and CA prime, of course, and your only concern is that at the right end CA prime should be equal to 0 according to my boundary condition, no matter whatever CA, but my concern is CA prime should be 0. That's all. So this condition forms the check on my method, right? So this would be basically used as a way to decide whether I have found a solution or not. Okay, all right. So 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 basically now if you start, so now if any of those could be your guessed value, right? Either y or d, CA or del CA by del Z, right? So the guessed value is, so what you do is uh, start with the guessed value. Let's say I am going to call that guessed value as S. Okay, it can be either CA or del CA by del Z at Z equal to 0. Okay, so this is what I'm going to call S. Whatever you are guessing, I'm going to call that variable as S, right? So calculate S, and then this would be basically you have to keep on updating S, okay, and keep on doing those calculations at the right end, okay, so that you meet your desired condition of the second boundary condition, that is this one. Okay, so keep on changing any of those CA or del CA by del Z. Okay, they will be dependent, interdependent through this equation. So one of them you choose, or one of them you guess, find the other one, solve the problem at the right end, check this value at the right end. If it is not met, you update your whatever the thing that you guessed, either this one or that one, you update those numbers, and then again do the calculation. Okay, so now here S, uh, so when you do it again and again, that's an iteration. Okay, so it's iterative. Okay, so iteration, suppose your iteration jth iteration, okay, then your updating of S is decided by the simple rule, which is basically an analog of Newton's method, minus, okay, so I have to define a quantity called G. Okay, GSJ is given by y at L minus whatever the boundary condition. So here actually G at L would be del y by del Z. Okay, sorry, so I want del y by del Z del y by, sorry, del y by del ca by del z. Actually, I'm calling y ca. Yes, Pawan, I'm just coming to your comment. Just a second. Del ca by del z. Okay, that's it. GSJ at z equal to 1. Okay, and that should be equal to 0. Okay, this is what I want. Okay, so GSJ, so if you define this to be your quantity that governs your updation of S, okay, then it's given by, the rule is simply G of Sj divided by G of Sj minus G of Sj minus 1, okay, into Sj minus Sj minus 1. Okay. So basically here it tells me that you have to do at least two calculations. So what I do is I calculate S1. S1 I don't calculate, I guess, right? Okay. And then S2 can also be guessed, which is also which can be equal to S1 plus some value, small value, let's say 1 e raised to minus 6, slightly change S value. Okay, and then see how does your G improve. At the other end, my condition improves or worsens. That's what I want to find out, right? So if I change little bit over here, initial guess, at the other end, does the condition improve or but worsens? That is basically the value change in G, right? Ideally, if G as J increases, its magnitude increases, your condition is becoming worse. If its magnitude decreases and then that means you are hopeful that, okay, if I keep on moving in the same direction from S1, okay, if I keep on adding more and more, for example, if I adding little bit of it, I get better result, I get smaller G at the other end, then you are hopeful, then you can keep on actually doing the same thing. So basically I need to have two uh, guesses, okay, or two marches from left to right done independently with two guess values, right? Okay, and then once I have done these two, I'm all set. So what I can do is I can actually then I can from here, for example, if I put j equal to 1, sorry, j equal to 2, then I have right hand side, everything is known, S2 is known, GS2 is known, GS1 is known, GS1 is known, and then I can calculate S3. Okay, so if I know S1 and S2, then S3 can be calculated. If I know S3 and S2, S2 and S3, S4 can be calculated, and so on. So therefore these two are needed to be performed before we start to uh, kind of automate it or start the iterations. Okay, now okay, so now there's some certain questions. Let me go back to your questions. uh, so first of all, Rohit, did it? No, Rohit, G is okay. Well, no, G is not Peclet number into CA minus 1. G would be basically, if you look at this, so here I want G where G to be, okay, let me probably show it by figure, then that would be probably clearer. So say this is my Z, okay, Z equal to 0, Z equal to 1. And here I do not know CA or CA prime at the left end. Okay, all I know is that right end, okay, the function should be, derivative should be 0. So maybe it goes like this. I do not know, but derivative should be 0. That's all I know. Okay, it should, the derivative at the right end should be 0. Okay, so this is the condition on right side, right? Del CA by del Z equal to 0. Okay, so now if I start, so now what I do is I guess either CA or del CA by del Z on left hand. Let's say I guess the CA value. Start from here. So let's say this is my first guess of that would be my S1. Okay, so S1 is going to be equal to CA at Z equal to 0. Okay, and that would automatically get me del CA by del Z as well. from the first boundary condition, because these two are related. So I know that at this point, if I choose this much Ca, then I know what is the slope. Okay. Now knowing this value and the slope, I can actually perform my Rangakatta calculation. Okay, and then reach at the other end. Okay. When I reach at the other end, okay, then it may meet. It may, just a minute, Rohit, let me explain this then. So it may meet this, and here when you solve this, remember your method allows you to solve for both Ca and Ca prime, which is del Ca del Z. When you solve it, you are going to get these values for Ca and Ca prime at each intermediate points. Okay, you're going to get these values at each point because you're solving for y, right? So if you recall, this is my equation. So when you're solving for y vector, you're actually solving for both Ca and Ca prime. So as a result, when you reach at the end, okay, when you reach at the end, you will get both Ca and Ca prime at the end. Okay, so you got both Ca and Ca prime at the end. This at, okay, this can be found by marching from left to right. Okay, and now what you do is you forget about this thing, just look at this value. Okay, if this value is 0, you are happy. Okay, because it has given you all the desired constraints that must be fulfilled. It has followed the differential equation in the regime. It has the initial boundary condition satisfied. It has a final boundary condition satisfied. Okay, therefore that's done. But if it's not 0, then what you do is you, whatever s you have chosen, either it can be Ca or del Ca del Z. I'll keep on reminding you this. Okay, but whatever S you have chosen, you just update it a little bit. Maybe so you, what you do is, suppose you meet over here like this. Okay, so your slope is not equal to 0 now. Okay, now what you do is you slightly change your S, maybe increase or decrease, I do not know, but that's your again guess. This can be plus or this can be minus. It's up to you. But whatever that there's a change, whatever the change is, you calculate using, now again with this one, your delta is del Ca by del Z will be again updated. Maybe the slope will slightly go down, and then again calculate this result and look at the other end. Has the slope changed or not? I mean, has the slope become better, meaning that are we approaching the slope to 0? When it has the slope decreased, if it was positive, or if it was negative, has it actually, basically its magnitude is basically becoming smaller or not? If you just compare that value, okay, then you see that if it becomes worse, meaning that like let's say if it meets at the larger slope than the first run, then you know that, okay, that would mean that moving this way is not going to help me, so I would like to come back. Okay, so I would not like to increase the Ca here, or S will not be increased. I would like to see decrease the Ca, then only probably you can, this number can be further reduced. Or if the trend is opposite, that means if I increase Ca and it becomes better, meaning its magnitude at the del of Ca prime becomes less at the other end, then you say, okay, then maybe I can go even further, then you can increase it even further. Okay, so by how much do you increase, that is given by this formula, which is basically to most, I mean, this is a formula basically a Newton's method, and this is this lets you to make those adjustment in the most efficient manner. You don't want to go for a very small step at each step or each small value of time, right? Each small updation, you can go to very small steps. Okay, so you can keep it this number very small and keep on going forever. But what you want to do is you want to do it in a efficient way, so that you achieve your desired result at the other end in the least number of steps. Okay, so that is what this scheme allows you to do. Okay, and this is all that we have. Now let me ask you, is that your question or not? Okay, Rohit, you say, so G is not local arbitrary, it's only at the, yeah, of course, exactly, G is at the end. G, if you recall, G, I had, yeah, so it's not, G is decided by uh, what is it that you want to, what is it that you want to become 0. Okay, so it's also called residual, by the way. There's a term, there's a technical residual. Okay, the quantity that becomes 0 as the solution is obtained, solution is reached. Okay, so here my quantity, the quantity that becomes 0 is this del C by del Z, right? As the solution is reached. So this gives you basically convergence, whether you have converged the solution or not. Okay, this is basically G of S. Okay, so this would be depending on, of course, iteration. So G of Sj is at jth iteration. What is my is basically error at the end. Okay, also think can be thought of as error at the end, which I want to minimize, and best case would be that would be 0. Okay, so is that all right? Okay, Pawan, you had a question. Let me go to your question. Taking a new assumption for S and then interpolate it between two results to know how should have been my assumption to get slope 0 at. So Pawan, what do you mean by that? So I guess what you mean by interpolating between the two results. Okay, so yeah, all right. So well, okay, so that's the question. How do you interpolate? Do you do linear interpolation? Meaning, if I take two value S, say S1, I get G1. S2, I get G2. Okay. Suppose G1 is positive, G2 is negative. Then do you do linear interpolation? Do you know that? I mean, with S, G will change linearly. Is that assumption? Well, actually, that assumption is kind of it's intelligent way, but again remember you have a better rule given here. Okay, so even so if the convergence is non-linear, okay, then this would be helpful. If the convergence is linear, then you may not get any difference between using this way or the way. If you're doing linear interpolation, then that way and this way will anyway give you the same result. Okay, so it's like for example, well, Newton's method, if you know, if there's a line that cuts versus a curve that cuts, right? Okay, so the linear case, you actually achieve your desired result in the least number of steps. Okay, not if it's a non-linear case, right? Okay, and linear case you just get in one step. Okay, so right, so well, maybe I'm spending time on this. Let me go to the codes. Well, there are some more questions. Let me answer those first. Okay, so Pawan, so yeah, you're right. You can do that interpolation, linear interpolation, but well, I am assuming that you're doing linear interpolation. If there are any non-linear interpolation, then that might work better. Okay, there are ways to interpolate. Yeah, linear. Well, so linear will take you. It will give you result, but it will take you much longer time because yeah. So it will take you much longer time. So that's where this formula comes to rescue. Okay, this is better than a linear convergence. Okay, it converges faster. Okay, by the way, all this discussion, we will see that actually, uh, when I look at the code, I'll show you that it actually doesn't work. Okay, there is something else that needs to be done, and that's what I want you to do again. Okay, so that's the purpose of this class. But let me. Okay, now there is some more questions. Akshat, Rk equation implementation. There are two equations in CA and CA prime and CA. Yeah. Okay, so okay, let me show you the code once, and then Akshat, let me show you the code. Then probably it become clearer to you. Okay, there are different ways of doing. Everyone can do in his own way. It's always good to be well. If you're in doubt, I always recommend that do separate equations separately. Okay, so that way you're likely to make less error. But if you're confident, you can use it in the form of vectors. Okay. So I'll show you, let me show you the codes first. Okay. So any more questions before I move on to showing how to implement, how we can implement it. and we can, what kind of problem we get with this implementation, and why do we get that problem, and how to resolve that problem. Okay, so that is what I want to talk now. So let me go to the MATLAB. Is the MATLAB screen visible? Is the MATLAB screen okay? All right, thank you. Okay, so here, first of all, what I have done is, so some of you sent me the code, and one thing I noticed that you try to make it as modular as possible, because then it's easy to fix it if there is a problem. So for example, I have, and also it's useful somewhere else. For example, this Rangakatta step, Rangakatta implementation, okay, that would be helpful in other problems as well. So I have made a different function. I'm calling it Rk4 Step underscore 2D. So two have two variables, okay. A vector has two numbers, okay, and what it does is it takes in a it takes in a input y vector current value and results the next y vector next. Okay. Other inputs are, of course, t or z, independent variable value, del t, the step size, current y value, f vec. F vec is basically, if you recall, I had del y over del t equals to f. That's what the question, probably the equation of Akshat relates to this. Okay, so this equation I'm going to solve, right? So this f vec is my f vector appearing on right hand side that decides the dynamics of y vector. Okay, so that I'm going to give a vector. I'm going to treat it as a vector now. Okay, so f vec is a vector. Okay, and f vec actually a function vector. Okay, so remember, you can, so f vec is a function, by the way. Okay, and you can pass a function to a function. That's a very nice feature. It's there almost all the programming languages, especially I know in C it's there, MATLAB is there. I don't know about Fortran, probably doesn't. I don't know, remember Fortran, but yes, C and C++ and of course MATLAB has it. So f vec is a function. Okay, let me just look at that function, and of course Peclet number and R, these are the constants. So the function that I'm talking about is over here. Okay, so remember, what is my function in my current case? Well, if you look at this, so this is my f1, this would be my f1, and this would be my f2. Okay, these are the two components of the function vector. So f1 would be equal to Ca prime, f2 would be equal to Peclet into Ca prime plus R into Ca, right? So that is what I have here. So y1, so this y I have defined to be my solution. Okay, this is my value y, which is these are basically two row vectors. Okay, and first row corresponds to the value of the solution, and second is the derivative. So y2 comma 1 is a derivative, and y1 comma 1 is a value, right? That is y1 comma 1 is Ca, y2 comma 1 is del C by del Z. Okay, so 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 well so what I do is I call y1 comma 1 as x. Okay, so x is the f vec. X value is given, x value is the input, right? So whatever x is, it returns its second one, meaning this second I mean, first index being 2 is actually equivalent to having a derivative, and first index being 1 is equivalent to having the value of the function, right? So this is the, so so this one, okay, this is my derivative and this is my value. So this is Ca and this is CA star. Okay, this one is CA star. Okay, this is CA star. So R into CA plus P Pecla into CA star, and this is CA star. These two values are returned. Okay, as you call the f vec, these two values are returned. Okay, so I think I probably stated it wrong. X is my solution vector here, right? That I sub so X I supply to f vec, and as a result I'm going to get the CA star of two numbers. One would be equal to CA star, other would be equal to R into CA plus Pecla number into CA star. These two numbers will be returned by this function. Okay. All right. So that is what actually that's what actually done over here. I'm sorry. Yeah. So Rk4 step. Now, and here is basically implementing the Rk4 step. We all remember this. Okay. So K1, K2, K3, K4. Remember, these are all vectors now. Okay. These are all vectors. So K1 is once, when I say once 2 comma 1, basically two-dimensional vector, right? It's a vector with two numbers. So these are all vectors K1, K2, K3, K4 with two numbers. Okay. And f vec also returns me two numbers, right? So when I do that, so K1 is, I'm going to get y vec has been already supplied to it. It will take this value. Remember, y vec is again a vector. Okay. When you call this function, you'll make sure that y vec is a vector. Okay. So we'll see the main script. This is still a function we are looking at. So this basically this file implements one Rk4 step. That means going from j to j plus 1. Okay, j point to j plus 1th point. Okay, this is one step. That's why I'm calling Rk4 step. And 2D, it's a two dimension, because if you have multiple dimension, this will not work. Okay, if you have more than more than two variables, this may not work. This will not work. That's why I have this 2 comma 1 defined over here. Okay, so having done this, then I go to the main script. Okay, so these are my functions that will be utilized in my calculation, and this is the script that script file which main driver basically. So here is these. Okay, so this is my script file. Okay, so these are just so these are essentially some of the definitions in the beginning. That is Pecla number, R. These numbers I have fixed. N is the total number of node points, including the boundary points. Okay, so that would be, remember always the number of section is one less than the number of total nodes. Okay, that would mean that there are 100 sections. If n is 101, there will be 100 sections. Okay, and that's 100 is a convenient number basically, because if you divide 1 by 100, I get 0.01 as my step size. Okay, this iter max is a number that gives me how many times how long I need to wait before I decide. Okay, before I decide that I have found the answer. Now this quantity y2 bc is a boundary condition, second boundary condition at the other end. Okay, so this is what is needed to confirm the y2 bc value is what we will require to check whether I have reached a solution or not. And these two are just defining initial G's and S's, right? We all remember what were G's and S's. Okay, then x min is 0, x max is 1, and del x I can calculate simply subtracting divided by the total number of intersection or sections, which is n minus 1. N is the number of total number of nodes. Okay, and solution array, derivative array, we'll come to that. Don't worry about this right now. Okay, all right, then okay, so now here what we're going to do is initial point is x min. Okay, and then we are going to march from left hand to right hand with first. Okay, so first guessed value, where is my first guessed value? Okay, okay, so here, so I had probably, I was trying different cases. So this set of instructions which I have commented out was, so y1 comma 1. Okay, first of all, I of course I have an array y of 2 by n, that's 2 row and n columns, right? So that would be basically these the way I have formed it is, you have a x axis or z axis, right? And it has n points, and each point I have two numbers, CA. For some reason this doesn't work well on the, I have CA and CA prime values at each point. Okay, so I have this two-dimensional array that I am defining here y. Okay, I'm just initializing it to -1 value at each point, meaning it will be having ones, all the value are -1 each. Okay, just this is initialization, nothing else. Okay, and it has first row, okay, that is 1 comma n. If it is the first entry is 1, that would correspond to CA, and second row is CA prime. Okay, and that is evaluated at each of the endpoints. Okay, and I initialize to be -1 at each point. Okay, then that is my initialization. Then I'm going to guess first thing. So y, here what I'm doing now is y2 comma 1. Okay, I'm putting it 1. Okay, y2 comma 1 is 1. That's my first guess. What I'm saying is, now I'm going to guess the derivative to be 1. Okay, and derivative to be 1, then actually the value of the function can be found by simply y1 comma 1 equal to 1 plus 1 by pe. You can see that, right? So if I know the derivative, then if I know the derivative, for example, here, right? So if I know the derivative, then CA can be found by simply 1, uh, CA can be equal to 1 plus derivative by Peclet number, right? So that's what we are doing here. Okay, so 1 plus 1 by Peclet number is my value of the function, and I'm calling S, my first S is the first guess value. That's it. Okay, the first S is first guess value. Okay, and then I do two calculations independently. Okay, two calculations, two first, that was the first guess, right? So first, with the first guess, I do the one calculation going from left hand to right hand. Okay, so that is over here. So this is my first computing. This is my first computing. So I going from 1 to n minus 1. That means starting from here and one point before the final one, and calculate my y, okay, by looking at this, right? So this will give me, remember Rk4 step gives me the next value, right? So I keep on doing it. So x is given by this number, y is given by whatever number you have supplied to y. Initially your guessed values will be supplied, and that will give me the I, that give me next one. Then again I take that y as an input to the Rk4 step, get the next one, and then again as a, so basically you're going from this way, you are actually proceeding, marching from left to right. Okay, having done this entire, after n minus 1 such repetitions of Rk4 step, uh, uh, Rk4 step, then I'll reach the value that I'll get at the end of this loop would be actually y at the end. Okay, so that is my G11. So that is my G11. I'm looking at the value y2 comma n minus y2bc. Y2bc is 0. Okay, this is my error. Okay, so the difference in the derivative, remember, see this, first entry is 2, that would mean I'm referring to derivative. So difference in derivative with the boundary condition is my error. Okay, that's my G11. Then again I do the same steps, except that now I would change y21 to little bit by Initially I had taken 1, now I'm taking 1 into minus 6, and S12 becomes equal to y2 comma 1 now, okay, and y1 comma, all everything else remains the same, and then you again do this calculation, and then I get G12 to be y2 comma minus y2 bc, same difference, okay. So these two I have found G values, and then I can further, I'm all set to do the next set of calculation from 3 onwards to my maximum number of iteration. I essentially do this. This is where I implement the iteration, the updation rule for S, right? So this is where we implement the updation rule, and then y2 is the guessed value of y2 is assigned same as S, okay, and y11 can be found from the backwards boundary condition. If you know the one, you can find the other one, and then this is essentially the same iteration in on, or basically it's a marching from left to right, okay, and after this entire thing is over, you calculate G, okay, and look at the absolute value of G. I'm just printing it out, okay, and this will keep on going on, so G will be updated, then again S will be updated, okay, Y's will be updated, again you do the calculation, again you do the march from left to right hand. This is the inner loop. So this is the inner loop, okay. uh, so inner loop is for the marching from left to right, and outer loop over here, this is for different guessed values for which you march from left to right hand, okay. So outer loop is for what is the guessed value of the CA or CA prime at the left end, and then inner loop is actually marching from left to right hand. So outer loop updates those guesses, and inner loop, this one, there are two loops, for ending here and this for ending here. So inner loop actually calculates, given the left hand value, it calculates the right hand value, okay. And outer loop, given the current guess, it gives me the next better guess, okay. That is my outer loop, okay. So doing this, you can actually do the calculation, and so, but the thing is, actually it doesn't work. So I'll quickly show you the result, and it actually gives me, well, without wasting the time, I'll just show you this over here. So this doesn't work, because if you look at the, I'm printing out the absolute value of G, that is error value, and it's huge, it's actually diverging, it's actually unstable, okay. So this is unstable, and the way out, the reason it's unstable is because of the method that we are using is actually conditionally stable, okay. This method is conditional, Rk4 is conditionally stable, but you can still work, okay. You can still get rid of this problem by doing the following, and I'll just do that, and I'll want you, so next I want you all to perform that, what I'm going to suggest now, and let me know, okay. So 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 basically what we are going to do next is we are going to march from, uh, left to right gives divergent solution if using Rk4. You can use trapezoidal here, okay. That will be one possible way out, okay. So rather than using trapezoidal, you can use implicit methods, okay, stable methods. So use trapezoidal method or backward Euler, okay. You can use that. Other way is that march from right to left, okay, right to left, okay. So what you do is here, you define a new variable, okay. Let me call that a new variable, which is zeta. Zeta is 1 minus z, that's it, which is so that now when zeta equal to 0, that would mean I'm at the z equal to 1, that means right end, okay, and zeta equal to 1, that would mean z equal to 0, that would mean left end, okay. And then express your equation in terms of, replace all dependence on z with dependency on zeta. So del by del z, okay, del by del z is equal to minus del by del zeta, and del square by del z square is going to be equal to del square by del zeta square. Okay, so with those, if you just rewrite the equations, okay, so rewrite, re-express the equations, the DEs and the BCs in terms of zeta. Okay. So what did we have there? We had initially del CA by del Z was equal to, I call it X, and let's say del X by del Z was equal to Peclet number into X plus RCA. This is what I had, right? This would change to del CA by del zeta equals to minus X, okay, and del X by del zeta, okay, um, that would be equal to uh, so now just let me write down this first. So your equation was del square CA by del Z square plus what was the equation? Let me see it again. Del square CA by del Z square minus Peclet number del CA by del Z minus RCA equal to 0. This would turn out to be del square CA by del zeta square minus, becomes plus Peclet number del CA by del zeta minus RCA, that is equal to 0. Okay, and your boundary conditions become what? Let me see. Yeah, so this would be your equation in terms of zeta now. Okay, and your boundary conditions become at the left end, that is zeta equal to 1. Okay, I had del CA by del Z. So at the left end, what were my CA minus 1 by Peclet number del CA by del Z, that is equal to 1. Okay, so in terms of zeta, that will become CA minus, becomes plus 1 by Peclet number del CA by del zeta, that is equal to 1. So this would become your boundary condition at zeta equal to 1, and zeta equal to 0, I have Z equal to 0 and Z equal to 1. I have del CA by del Z is 0, which is the same as del CA by del zeta equal to 0. Okay, so now I have everything expressed in terms of zeta coordinates, which is actually Z moving from zeta moving from 0 to 1. Okay, is like Z going from 1 to 0. Okay, all right, so this is 0 to 1, Z going from 1 to 0. Okay, that's why it's called right, traveling from right to left. Okay, so now if you just recast so you have now, I have already given you original. When you had in terms of Z, you saw the code, right? All I want you to do is just modify that code and now do it using using this in terms of zeta, and then then you look at the result. This should converge actually. So now compute using zeta. So I have new set of differential equation to solve. Okay, and this should converge. This should be stable. Check this. Okay, that's what I want to do. So I just gave you a method which is, I just basically I showed you how to calculate this and applied it to this, and but it turns out that it's unstable, and there's a way out. Way out is that you go from right to left instead of going from left to right. Okay, there are questions. Let me go to the questions. Why are we running the outer control loop of second effective iter max? We can use while statement. Yeah, we can use while statement. Of course, we can use while statement. The thing is that I already knew, I wanted to demonstrate, I knew that it's not going to converge. So therefore, I just, of course, so I just showed it that for few iterations, okay, I can show you the values of the, So let me just show you this CLC, and let me just try to run it over here. So the purpose is that to show the values, not to show the convergence, but to show the fact that this G actually goes to very high values, right? The error shoots up. Okay, so this abs, this thing is what is being printed here, and this goes to 10 to 49. This is unstable. I didn't want to bother to. I already knew that this is going to blow up, and that's what I wanted to demonstrate here. Okay, but if you do that other way, if you go from right to left, okay, if you go from by in terms of zeta, you just do the computing, and then you can see that it's actually it should converge. You will get a final answer. You'll get a good result using that technique. That small modification actually solves the problem. Okay. So Akshat, was that the question? We can use while statement with conditional error. Of course, yeah. That way the error in calculating due to steep gradient descent will be minimized. Error, no, the error is already updated. There is updation rule. Okay, 2:45. We'll stop the class now. We have a class, looks like, so I'm going to stop now. Okay, okay. So, but I want you to try this next, and then Brigya, instead we will have to guess CA on right. Yeah, absolutely, exactly. You have to guess exactly. So you have to guess CA on right end, and then travel backward. Exactly, that's what you have to do. So you have got the idea, and del CA by del zeta is 0. All you need to do is just CA at the right end. You have to identify to be some number, and then do the calculation. All right, and then you have to, this would become your condition to check at the left end. Okay, this would become your condition to check. This would be your S. Okay, oh sorry, G. This -1 would be equal to G of S. Okay, all right, so S will become CA at the left right end, and G of Sj will become essentially this -1 would be your G of Sj, so that when this is 0, I'm done at the left end. Okay, all right, so please check that, and this should work. Okay, all right, so I'm going to stop the class, and expecting your codes today, or by definitely by tomorrow. Okay, because I've given you most of the error is changing sign midway. That's why its absolute value blows up. Error is changing sign midway. What do you mean by that? How do you know that error is changing sign midway? Akshat, I'm unable to get your question. If we can talk about this, let's talk, okay? Because right now I have to stop the class because others have classes. So let me stop the class now, okay? All right, okay. Bye bye.